Gautamprasad Patel from Hasmukh Goswami Engineering College. Today lecture on question paper of semester examination May-June 2012. My first question is: solve the following homogeneous system of linear equation by using Gauss-Jordan elimination. And the system is given that 2x1 plus 2x2 minus x3 plus x5 equal to 0. Similarly, second equation is minus x1 minus x2 plus 2x3 minus 3x4 plus x5 equal to 0. Third is x1 plus x2 minus 2x2 minus x5 equal to 0. And similarly, last one is x3 plus x4 plus x5 equal to 0. Here number of variable is 5 and number of equation is 4. So we write the augmented matrix for the system is like this one: 2, 2, minus 1, 0, 1 and 0. All first 2, 2, minus 1, 0, 1 is the coefficient of variable x1, x2, x3, x4 and x5. And similarly, second row is second equation coefficient minus 1, minus 1, 2, minus 3, 1 and constant coefficient is 0. Similarly, third is 1, 1, minus 2, 0, minus 1, 0. And last one is last equation coefficient is 0, 0, 1, 1, 1, 0. Now to solve it, we convert in reduced row column form by row operation. So first convert find leading one. So leading one is 1 by operation row operation is R13. So we interchange this. R13 means interchange first row with 3. So first row becomes third and third row becomes first. So we get 1, 1, minus 2, 0, minus 1, 0. And third row is becomes first 2, 2, minus 1, 0, 1, 0. And another 2 are as it is. Now next is by apply R2, R1 to 1 and R1 3 minus 2 means convert first leading first column another without leading one or another all elements be convert in 0 form. That means 1, 0, 0, 0 first column. So we apply operation R1 2. That means multiply first row by 1 and add in second. So this minus 1, 1 minus 1, 1 plus minus 1 becomes 0. That means this 0. Similarly for all column elements, that means 1 multiplied by 1 in second column, and there it's also becomes 0. Minus 2 multiplied by 1, so it's minus 2 and plus 2, so it's 0. Similarly 0 into 1 is 0 plus minus 3. So it's minus 3 minus 1 into 1 is minus 1 plus 1, so it's 0. Next similarly R1 3 minus 2, that means first row multiply by minus 2 and add in third row. So minus 2 into 1, so it's 0. Next 1 into minus 2 plus 2, so it's 0. Similarly minus 2 into minus 2 and add, so 3, and next is 0, 3, 0. Similarly we find all addition by applying this operation, so we get 0, 0, 3, 0, 3 and 0. And last row is already in 0 form, so as it is, so 0, 0, 1, 1, 1, 0. Now next step is once again find next leading one. So next leading one is in next leading one in third second row third column, but here with 0 entry. So we rearrange this row by interchanging the any row. So here in second row it's non-zero element in this column. Sorry, third row in non-zero element in this column. So we interchange second and third. So R2 3. That means second row convert in third and third is in second. So second becomes 0, 0, 3, 0, 3, 0, and third is 0, 0, 0, minus 3, 0, 0, and first and last one as it is. And next step is convert in 3 1, so it's by multiplying second row by with 1 by 3, so it's becomes 0 0 1 0 1 0, and another all row are as it is, that means 1 1 minus 2 0 minus 1 0, and third and similarly fourth one. Now using this leading one in that means in third column and second row 1, using this convert this third row in this third column 0, and fourth row in third column it's also 0, but in already in third row it's already 0, so we only convert in 1 in means third row and fourth row and third column in 0, so multiplying by minus 1 and convert 0. Similarly here Gauss-Jordan method, so first row also convert in 0, so 1 multiplied by 2 and add in first, so minus 2 plus 2 is 0. Similarly in all row element multiply by and adding similar corresponding element, so we get this answer 1 1 0 0 1 0 0 0 1 0 1 0 0 0 minus 3 0 0 and 0 0 1 0 0. Now we next find next leading one. So in next leading one in next row and next column means third row and fourth column, so it's 1 it's a minus 3, so we convert this minus 3 in 1 by using operation R3 minus 1 by 3, that means multiply by third row with minus 1 by 3, so we get in third row 0 0 1 0 0. Now using this leading one, that means third leading one, we apply operation row operation R3 for minus 1, that means convert fourth row third element, that means fourth row third column element in 0, but and here remaining all are in 0, so only operation R3 for is exists, so R3 for minus 1, so we get lastly 1 1 0 0 1 0 is first row, 0 0 1 0 1 0 0 0 1 0 0, and last one is all elements are, that means the last row is 0. So this is last operation row operation, because in next leading one is does not exist, because in fifth row all elements in 0, so next leading one is does not exist, so we take the corresponding system of equation is now first row first column element is 1, so x1, next is 1, so x2, next 0 0 into x3 is 0 0 into x4 is 0, 1 into x5 is 1 equal to 0, that means our first equation is x1 plus x2 plus x5 equal to 0. Similarly in second row, so 0 into x1 0 0 into x2 is 0, 1 into x3 is 1 x3, 0 into x4 is 0, 1 into x5 is x5, and 0 into 0 is our constant term, so we get the next equation is x2 x3 plus x5 equal to 0. Similarly third is only x4 is constant is non-zero, so x4 into 1 is x4, and remaining all variable coefficient is 0 0 equal to 0, so we get x4 equal to 0, and last row is 0 equal to 0, because all coefficient is 0 0 equal to 0. Now solving the for the leading variable, so we get x4 is 0. Now x3 equal to minus x5, x1 plus x2 plus x5 equal to 0, so x1 equal to x2 minus x2 minus x5, so we get x1 equal to minus x2 minus x5, x3 equal to minus x5, and x4 equal to 0. Now we take free variable, that means x here x5 and x2 are free variable, because its answer is not exist, that means it's a free variable, and for this free variable we take parameter rn, not r, here s and t, so we get x1 equal to minus st minus s minus t, x2 equal to s, x3 equal to minus t, x4 equal to 0, x5 equal to t, that means we get take x2 is parameter s and x5 equal to t, so this is our general solution, that means it's the last solution, and it's last answer of the question number 1a. Now my next question is question number 1b, and its first question, that means sub question is find A inverse using row operation. That means in similarly last example this apply row operation, but here to find A inverse, that means inverse of the matrix A. So we apply in this form A oblique I. That means A is our given matrix and I is identity matrix. That means here 3 cross 3 matrix A. Therefore identity is also take a 3 cross 3 matrix. Now apply row operation and convert this A. That means here A is this A in identity, and similarly in a parallel I convert in another matrix and it's called A inverse. So we apply operation. That means here first find leading one, and already here leading one, so 1. So using this in first row first column 1, using this apply in first column 2 and 1 converting 0. So apply R1 2 minus 2. That means first row multiply by minus 2 and add in 2. So it's 0. Similarly for on all column. So we get in second row is 0, 1, minus 3. Similarly in identity matrix, so minus 2, 1 and 0. Now in third row, so R1 3 minus 1. That means first row multiply by minus 1 and add in 3. So we get 0, minus 2, 5, and in identity minus 1, 0, 1. Now next step is find another leading one. That means next leading one is 1, and here already 1. So using this we convert remaining another in this column another element in 0. So R2 1 minus 2. That means multiply second row by minus 2 and add in 1. So we get 1, 0, 9, 5 minus 2, 0. Here 1 in first leading one as it is, because in this column all elements is 0. So multiply by any value and add in this is always answer is 1. And similarly for third row, so second row multiply by 2 and add in third. So we get 0, 0, minus 1. Similarly in a parallel matrix it's convert in minus 5, 2 and 1. Now we find next leading one, and it's in third row. So here in next leading one its value is minus 1. So we multiply R3 by minus 1. That means in third row by minus 1. So we get in third row is 0, 0, 1, and parallel matrix in 5, minus 2 and minus 1. Now next step is now we convert in third column another element except leading one in 0. So here operation is R3 1 minus 9. That means third row multiply by minus 9 and add it 1. So we get 1, 0, 0, and similarly parallel matrix first row is minus 40, 16 and 9. Now R3 2 into 3. That means third row multiply by 3 and add in second row. So we get 0, 1, 0, 13, minus 5 and minus 3, and last one is as it is. That means 0, 0, 1, 5, minus 2, minus 1. Now left hand side matrix convert in identity of 3 cross 3 matrix. That means 1, 0, 0, 0, 1, 0, 0, 0, 1, and parallel matrix is our A inverse. That means given matrix inverse. So this last hence A inverse is minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2 and minus 1. This is our last answer. Now next question is question number 1b2. That means sub question of question number 1b. Solve the system of equation. Here given system of equation variable is a, b and c, and here three equation. First is minus 2b plus 3c equal to 1, 3a plus 6b minus 3c equal to minus 2, 6a plus 6b plus 3c equal to 5 by Gauss elimination method. This is same to Gauss Jordan method, but here minor difference is find upper lower triangular. That means row echelon form. So the augmented matrix for this system means this is our augmented matrix. Last example number 1, question 1a. So here augmented matrix is 0, -2, 3, 1. That means first 0 minus 3 is coefficient of first equation and 1 is constant coefficient. Similarly, second equation coefficient is 3, 6, -3, -2, and third is 6, 6, 3 and 5. Now here apply reducing in row echelon form. That means in diagonal element here square matrix means coefficient matrix is square matrix. Therefore we say that the diagonal means this 3, -2 and 3, it's a diagonal element. So we convert this diagonal element in leading one, and using this we convert in remaining lower all elements in 0, 0. So reducing the row echelon form, so multiply first row by 1 by 3. So we get 1, 2, -1 and -2 by 3. Now here leading one is first row, first column. So using this leading one, convert remaining all column element in 0. So here second is already 0, only convert in last row element of first column by using of row operation R13 into -6. That means last row is converting 0, -6, 9 and 9. Now we next find is next leading one in second row and second column. So second row second column element is -2. So we multiply this second row by -1 by 2. That means row operation write in form R2 -1 2. So we get 0, 1, -3 by 2 and -1 by 2. So now using this second leading one, convert lower element means in this column leading element in 0. So -6 convert in 0 by multiplying second row by 6 and add in third. So we get in last is